Number 9, we are going to learn a technique. It's called a prime factor a whole number. This technique is very basic and useful. Prime factor a number. Let me write down the definition. Prime factor a number. The number here refers to a whole number. Is to write the number as a product of all its prime factors. First, let's clarify the definition of a prime factor in a number. Write it down. We are going to learn the technique, but firstly, we have to know what is prime factor in a number. It refers to a process. During the process, we write the number as a multiplication of all its prime factors. Here we have a keywords, prime factors. So let me explain. How do we understand prime factor? Remember 15? We are able to write 15 as 1 times 15. We can also write 15 as 3 times 5. All right? Yeah. And 15 has in total 4 different factors. We went over this last time. The 4 different factors of 15 are 1, 3, 5, 15. And among the 4 factors of 15, which of them are prime numbers? A prime number is a whole number bigger than 1 and only has 1 and itself as 2 different factors. We have learned the definition for prime number last Wednesday as well. Yeah, anyone can tell me for 15, it has 4 different factors. Yeah, which of them are prime numbers?
5.
Is 1 a prime number? Yeah, 5 is a prime number. Is 1 a prime number? Is number 1 a prime number?
No.
No? Okay. Yeah. It's better that I can hear you. I don't have to go back and forth to look at your message. Exactly. 1 is not. 3 is a factor, right? I mean, 3 is a prime number, right? And
Yes.
15 is,
Yes.
yeah. So 15 has 2 prime factors. As you can see, 3 is a prime number. 3 is a factor of 15. So that makes 3 a prime factor of 15. Is a prime factor of 15. Same with 5. 5 is a prime number, and 5 is a factor of 15. That makes 5 a prime factor of 15. So 15 has 2 prime factors, and this equation, on the right side of the equation, we wrote 15 as the multiplication of 3 and 5. We write 15 as the product of all its prime factors. And this actually, the right side only, the right-hand side, this product is the prime factorization of 15. This is the prime factorization of 15. All right? We can write 15. If we write the number 15 as the multiplication of all its prime factors, 15 has 2 prime factors. If we write 15 as the multiplication of all its prime factors, then that process is prime factor 15. And the right-hand side, 3 times 5 is the prime factorization of 15. I think this would help us to understand the process of prime factoring a number and what is a prime factor of a number. The focus is to learn how do we prime factor a specific whole number. Yeah, what about this one? We can also write 15 as 1 times 15, right? Yeah, that is also a factorization of 15. 1 times 15 is also a factorization of 15, but it's not a prime factorization. I want you to see the difference. Yeah, we have two different ways to factor 15. We can write 15 as 1 times 15. We also can write 15 as 3 times 5. 1 times 15 is a factorization of 15, but it's not a prime factorization of 15. And the prime factorization of 15 is 15 equals 3 times 5. Yet in the multiplication, all the factors are prime factors. So that's very important. Yeah, let me show you how do we prime factor a number. Let's start from number 12. I use a big L technique. I hope you learn the technique. So whenever you need to factor, whenever you need to analyze a number, whenever you need to prime factor a whole number, you are going to write the number down and then put the number on a big L. Okay? You might remember in middle school, your teacher used the tree method, but I do not like that method. It's very taking up a lot of space. I use the big L technique. So draw a big L, capital letter L, like this, right? Or you can see that as a stair. Draw a big L and put a 12 on top of on the big L. And I start from looking at the number and to see if the number even or odd. Yeah, 12 is even, right? If a number is even, then the number has a factor of 2. So 2 is a prime number. We have the first prime factor of 12 found. So we put a 2 to the left of the big L. Divide 12 by 2, what do we have? Yeah, let me repeat what happened. I'm going to, I am prime factor 12. So I draw a big L, place 12 in the big L. And since 12 is an even number, it has a 2 as a prime factor. So I put a 2 next to the big L, on the left of the big L. And I use 12 to divide by 2. I have 6. And 6 is not prime, right? If the number on the bottom is not prime, we're going to keep going and draw another big L. Knowing my notation is stairs, not a wall. Is stairs, not a wall. And 6 is also even. Since 6 is even, 6 has a prime factor 2 as well. And we divide 6 by 2, we have 3. Is 3 prime? When you have a prime number on the bottom, then the process is done, okay? We can write 12 as 2 times 2 times 3, you know? 12 is 2 times 2 times 3. And 2 and 2 and 3, those 3 factors are all the prime factors of 12. And we wrote 12 as the product of all its prime factors. And we found the prime factorization of 12. So the process is complete. Any questions about that? The number is equal to the product of those numbers. And those numbers around the stairs, they are prime factors of 12. Those numbers have to be prime, by the way. Those numbers around the stairs have to be prime. All right.
Breaking it down like this helps a lot. So
writing it down help a lot.
Yeah, breaking it down like this helps.
Yeah, okay. So let me do another one, and I want you to practice the rest. I'm going to do 75. I'm going to prime factor number 75. Use my big L technique. By the way, I teach the method I think is very useful and efficient. Certainly, you might know some other methods. You are welcome to apply any method you feel comfortable with. The important thing is you are able to get a problem done correctly, right? Yeah, I'm just recommending my method. For 75, is 75 even number? If not, then we cannot do 2, right? Oh, 3 times 25. Dakota, remember we're prime factoring number 75. So maybe you are just telling me the first step. Yeah, 25 is not prime, so we have to keep going. Yeah, I would start from 5. The reason is because of this. If the last digit of a number is 5 or 0, then the number is divisible by 5. Divisible by 5 means have 5 as a factor, and 5 is prime. So if the last digit of a number is 5 or 0, then the number has a 5 as a prime factor. That's the reason. So I start from 5. Divide 75 by 5. I have 15 as the quotient. 15 obviously is not prime. Then we're going to keep going. Draw another stair, big L. And 15 has 5 as the last digit as well. So 15 has 5 as prime factor. And divide 15 by 5, we have 3. And 3 is a prime. So the process is done. Yeah, whenever you have a prime number on the bottom, that means you are done with the process. And you can write 75 as 5 times 5 times 3. Yeah, you must make sure all the factors in the product, they are prime numbers. 3 is prime, 5 is prime, 5 is prime. But if you only write 75 as 3 times 25, that factorization is not a prime factorization because 25 is not a prime number. In order to be the prime factorization of a number, all the factors in the multiplication must be prime numbers. Do you have any questions? Anybody want to ask the question? For example, 12. Is that correct? We write 12 as 3 times 2 times 2, or 2 times 3 times 2, and write 75 as 5 times 3 times 5, or 3 times 5 times 5. Would the order of those prime factors in the prime factorization matter? It doesn't matter. Okay, guys? Yeah, the order does not matter. No questions? I got it finally. Okay, thank you, Killen. Yeah, I'd like you to try. Yeah, I'm not sure how do you share and I can see your work, but I would like to give you some time. Then you can work on those problems. And if you have trouble to get it done, you let me know. Okay, I did 12. I did 75, and you are going to do 20, 50, 98, and then 31. I give you 5 minutes. Okay? Yeah. Work on it. At the same time, I will give you the answer after the 5 minutes actually. Yeah. Right now it's 22. I'll get back to you at 27. Please feel free to let me know if you have a question that you don't know how to prime factor the number. Or later when you see your solution is different from mine, and also let me know.
Could you possibly put on the screen your tricks that you had typed up? I didn't get all of them wrote down.
Yeah, right here.
Yes, thank you. Thank you so much.
No problem. No problem. 20 equals, exactly. Thank you, Taylor. That's correct. Yeah, we have Taylor get a number 20. Done. 20 is even, so it's a 2, has a 2, and then divided 20 by 2, I have 10. 10 also has a 2 as a factor, and then the quotient is a 5. So 20 equals 5 times 2 times 2. All that matters is you make sure all the factors in the multiplication are prime numbers. Very good. 50. Exactly. Thank you, Jill. That's also correct. 50 equals 5 times 5 times 2. You guys are great. 5 is prime, 5 is prime, 2 is prime. And 5 times 5 times 2 is 50. Very good. $98. Awesome, exactly. 98 is a pretty big number compared with other numbers. 98 is even. So divide 98 by 2, you have 49. 49 is 7 times 7. We went over those perfect squares at the very beginning of this unit. Thank you, Ashley. That's awesome. 7 is prime, 7 is prime, 2 is prime. We have one more, right? 31. How do we prime factor 31? Is 31 divided by 2, divided by 3, 5, 7? You are right. Thank you, Jill. 31 is a prime number. We cannot prime factor the number, or it's meaningless to really prime factor 31. Yeah, if we want to write, it's just 31 equals 31. Okay, please do not write 31 times 1. That's not a prime factor because 1 is not a prime number. Okay, very good. You guys are great. So that's a very important technique, big L technique. We use this technique to prime factor a number. Now, why do we need to learn how to prime factor a whole number? Because we need to use that technique to learn how do we find a GCF and LCM for any given two whole numbers. All right, let's start from GCF first. The example I have is to find the GCF of 30 and 36. I have a process, three-step process. If you apply the three-step process, you can find the GCF for any given two numbers. Sometimes we need to find a GCF for 3 or even more numbers, but we only cover the GCF of 2 numbers. Use the technique, you can actually generalize to find a GCF for 3 or more numbers. Yeah, what is the three-step process? Step 1. By the way, what does GCF mean? Anybody remember what does GCF stand for?
Greatest common factor.
Perfect, exactly. Yeah. Greatest common factor. That means the number we are looking for, yeah, greatest common factor of 30 and 36. The number we are looking for is a factor of 30. It means it goes into 30 completely, a whole number times, yeah, and also goes into 36 completely.
So would it be 6?
And yeah, it is 6. Yeah. So for some numbers, you might be able to identify if you have a good foundation from previous education. You'll probably be able to identify the GCF right away. But the purpose or the point of this problem is to show you my three-step process. Then later, when you have bigger numbers, you also can find the GCF correctly. Yeah, it is 6, but let me do my steps. Yeah, let me show you the procedure. The first step is to prime factor both numbers. Okay, yeah. So we can do 30 and 36 separately right here. 30 is even. Divide by 2, have 15. 15 is 5 times 3 or 3 times 5. So we have 30 equals 2 times 5 times 3. 36. We need a prime factor 36. Is even. Divided by 2, have 18. 18 is even. Divided by 2, have 9. And 9 is 3 times 3. Yeah. This process is the prime factor a whole number process. So we have 36 prime factored as 2 times 2 times 3 times 3. All right? Yeah, after I prime factor both numbers, I place the two prime factorizations vertically. Align them like this, as you can see. Align them vertically like this. And then step 2 is pretty straightforward. Read the bubble, I'll explain what I mean. Common prime factors. Okay, look at the common prime factors of 30 and 36. 30 is 2 times 5 times 3. 36 is 2 times 2 times 3 times 3. As you can see, both two numbers have 2 as a prime factor. So 2 is a common prime factor. And besides that 2, we also have this 3 is common, right? 3 is a prime factor of 30. 3 is also a prime factor of 36. So 3 is common. Any other common prime factors? 5 is not common. And we don't have this 2 because 30 don't have an extra 2 to match this one. And 30 doesn't have an extra 3 to match this one either. So that's it. So 30 and 36 only have 2 common prime factors. In this bubble, we have 2. In this bubble, we have 3. And step 3, all we need to do is to multiply them all together. In the first bubble, we have 2 2's, but we only write it down one time. So step 3 is to multiply the bubbled common factors. So 2 times 3 give us 6. 6 is the GCF, the greatest common factor. 6 goes into 30 5 times. 6 is a factor of 30, goes into 30 5 times. 6 is a factor of 36, goes into 36 6 times. And 6 is the biggest common factor of the two numbers. You are not able to find a bigger number than 6 that could go into 30 and 36 both. A common mistake is to see 3 as a GCF because 3 is bigger than 2, and which is incorrect. 6 is the biggest common factor. Yeah, I want to make sure not just some of you understand it. I want to make sure every single one understand it. As I said, if the two numbers are pretty simple, you don't have to. You might be able to identify the GCF right away without applying the process. But the point of this example is to give you the process, then you can apply to find the GCF correctly for any given two whole numbers. All right, that's GCF. And I want you to help me to work on these problems, okay? Practice. Whatever the method you use, help me to find the GCF of 10 and 30 and the GCF of, let's do 7 and 28. How about that? Take your time. Find the GCF for 10 and 30.
Do you want us to say the answer out loud or just wait?
Sorry, I couldn't hear you well. Find the GCF for 10 and 30.
Do you want us to say the answer out loud, or do you want us to wait?
Oh, I want you to write it down. I actually want you to apply the process. Add one more. Two times 5 is 10. Yeah, 10 equals 2 times 5. And what's the GCF of 10 and 30 though? You can write a sentence. The GCF of 10 and 30 equals. Yeah, 10 is correct. And what's the GCF of 7 and 28? 7 is highest in 7, then it goes into 28 as well. Yeah, exactly. You actually see it. Thank you, Killen. And what about the GCF of 21 and 4? What's the GCF of 21 and 4? Awesome. Thank you, Killen. I think you have very good sense of math. You have good foundation. Yeah, it is. Let's see how do we get an answer, all right? I want you to write down two special cases here. I'm going to type here. Special case number 1. Let's say we have two numbers. Whole numbers, okay, by the way. Let's say we have two numbers. If the smaller number, when we have two different numbers, of course, one number is smaller, the other is bigger. They are both whole numbers, means they are positive, not negative. Say we have two numbers. If the smaller number happens to be a factor of the bigger number, then the smaller number is the GCF of the two numbers. Say we have two numbers. If the smaller number is not capital happens to be a factor of the bigger number, then the smaller number is the GCF of the two numbers. GCF of 10 and 30 is 10, GCF of 7 20 is 7, GCF of 21 and 4 is 1. Exactly, Paulina. It's awesome. Yeah. We are trying to analyze or summarize some conclusion, and you can remember. Then in the future, when you see similar problems, you can get it done in 1 second. All right. So I want you to write down two conclusions. The first conclusion is about the first special case when we look for GCF, or actually LCM. Later I'll show you. If we have two numbers and the smaller number happens to be a factor of the bigger number, then the GCF of the two numbers is the smaller number. Yeah, why? Let me explain. Look at the 10 and 30. Kaylin just now actually explained very well. 10 and 30. 10 is the smaller number, 30 is the bigger number, right? And 10 happens to be a factor of 30. 10 goes into 30 3 times. 30 is a triple of 10. By the way, this does not happen all the time, okay? Yeah. Earlier we have 30 and 36. The smaller number 30 is not a factor of 36. So that's the reason I say the situation is a special case. It doesn't always happen, but when it happens, we have the conclusion to refer to and then find the GCF very quickly. Then we know the smaller number is going to be the GCF. The reason is 10 is the biggest factor of itself. 10 is also a factor of 30, and that makes 10 the biggest common factor of both. I want you to really see it, the reasoning, because GCF refers to the biggest common factor, right? Yeah, we are looking for a number. The number is the biggest common factor of 10 and 30. Yeah, it's a factor of 10, it's a factor of 30, and it's the biggest factor that can go into both. And 10 is the biggest factor of itself. 10 is the factor of 30, and that makes 10 the biggest common factor of both. Similar with 7 and 28. 7 is a factor of 28 because 7 goes into 48 4 times. That makes 7 the GCF of the two numbers. It's because 7 is the biggest factor of itself. 7 is a factor of 28. That makes 7 the biggest common factor of both. All right. For number 3, we have another special case. I want you to write a note about special case number 2. The focus of today is the two special cases. If two numbers have no common factor except 1, then the two numbers are co-prime. If two numbers are co-prime, then their GCF is 1. That's the second special case I want you to write down on your note. It involves a definition, co-prime. Co-prime describes a special relationship between two whole numbers. If two numbers, they have no common prime factors, and the only factor of the two numbers is 1, then the GCF of the two numbers is 1. Yeah, let's take 21 and 4 as an example. If we are to factor 21, prime factor 21, we have 21 equals 3 times 7, right? Yeah. 2, 1, add up to 3. 3 is divisible by 3, so we know 21 is divisible by 3. 3 is a prime. Divide 21 by 3, we have 7. 7 is a prime. So 21 equals 3 times 7. That's the prime factorization of 21. And 4, 2, 2, right? Equals 2 times 2. Based on the 3-step process, the second step, we are going to bubble the common prime factors. But we have nothing to bubble because the two numbers, 21 and 4, they do not have shared common prime factors, right? 21 is 3 times 7. 3 is not a factor of 4. 7 is not a factor of 4. And the prime factor of 4 is 2. And 2 does not go into 21 completely. So those two numbers are co-prime. Yeah, when the two numbers have no common prime factors, but they do have a common factor. Those two numbers do not have any common prime factors, but they do have a common factor. The common factor is 1. Think about if your parents only have you as one child. You are the only child of your parents. Then does that make you the oldest child of parents? So if 21 and 4 only have 1 as a common factor, of course 1 is the biggest common factor of the two numbers, right? Does that make sense? So that's the second special case. I want you to please remember the definition of coprime. Coprime is a very important concept. If two numbers are coprime, then the GCF of them is definitely 1. So 21 and 4 has GCF 1. Let's try 4 and 7. Anybody can help me to find the GCF of 4 and 7? What's the GCF of 4 and 7? Awesome. Yeah, exactly. Because they are coprime. Yeah. What about GCF of 3 and 5? Yeah, Amanda, thank you. Sean, Kaden, exactly. GCF of 4 and 7 is 1. GCF of 3 and 5 is 1 as well. All right? Yeah. So here, let's look at the 3 cases. Three problems. They belong to the second special case, right? The second special case, the given two numbers are coprime. Yeah, let's look at the first problem. First question. 21 is not prime. 21 is a composite. 4 is a composite. But the two numbers are coprime. GCF is 1. And this question, 4 is a composite. 7 is a prime. Yeah, 1 is a prime, the other is not. And turns out they are coprime. GCF is 1. And this question, 3 is prime, 5 is prime, and they are coprime. GCF is 1. So here I want to clarify a misunderstanding. I'm going to type here. A common mistake. I want to clarify that if two numbers are both prime, then they are coprime. But two numbers are coprime does not necessarily mean both of the two numbers are prime. Okay, yeah, write the sentence down and then we are going to understand the meaning. If two numbers are both prime, then they are coprime. GCF is 1. Yeah, please have those in your note, and because we're gonna use them later in later chapters. If two numbers are both prime, like 3 and 5, if two numbers both are prime numbers, then they are definitely coprime. GCF is 1. However, If two numbers are co-prime, we don't know. We cannot say they are both prime. You see the difference. Two numbers are co-prime. Two numbers are both prime. They are two different things, right? If two numbers are both prime numbers, they are definitely co-prime. But the other direction is untrue, is not true. If two numbers are co-prime, we have those three cases. Yeah, they could be both prime numbers like 3 and 5. Could be one number is prime, the other is composite like 4 and 7. Or they both could be composite like 21 and 4. So the only reliable way to determine if two numbers are co-prime or not is to use the process. To make sure they do not have any common prime factors. Yeah, I'd like to copy it down. This means to determine if two numbers are co-prime, we should apply the three-step process to see if they have no prime factors. Yeah. Only when they have no prime factors, they are co-prime, and GCF is 1. Yeah, please let me know those paragraphs, those conclusions. Yeah, do they make sense to you? And make sure you have them in your note, and the next time when you look at it, they still make sense to you. Yes or no? Yeah, okay. Thank you, Belina. Thank you, Sean. Thank you, Amanda, Desiree. Awesome, very good. Don't forget this, okay? First special case for GCF, and the second special case for GCF. Don't forget that. Okay, thank you, Kaylin. Thank you for the positive feedback. All right, now let's look at LCM. Anybody can remind me what does LCM stand for?
Least common multiple.
Exactly. Least common multiple. Least common multiple. When we look for the LCM of two numbers, we're looking for a number that is a multiple of 30. Yeah, let's say 30 and 36. When we look for the LCM of the two numbers, we're looking for a number. The number is a multiple of 30. Also a multiple of 36. Yeah. We actually, in fact, can find infinitely many common factors for 30 and 36, but we concern the smallest common factor. Even the common factor we're looking for is the smallest, the number is still should be bigger than 30 and 36. You see what I'm talking about? Yeah, it's kind of like confusing because GCF has greatest has this word in it, greatest, but actually GCF of two numbers is a relatively smaller number, and LCM of two numbers is a relatively bigger number compared with the two numbers, but even it has the least this keyword in it. So make sure it doesn't confuse you or mislead you. Three-step process to find an LCM for any given two numbers as well. Okay. If you apply the 3 steps, you could always find the LCM for any given two numbers correctly. So step one. In order to find the LCM for 30 and 36, firstly, we prime factor both numbers. All right, that's the first step. Yeah, that's the reason we need to learn the technique prime factor number, right? Prime factor both numbers. And you know, we have it done earlier. I'm not going to do it again. I'll just write a factorization here. We have 30 equals 2 times 3 times 5, or 2 times 5 times 3, doesn't matter the order. We have 36 equals 2 times 2 times 3 times 3. The second step, same with earlier, I align the two prime factorizations vertically, like that. Second step, write a bubble. Common prime factors. And blue, you know, you can choose your own color. No, we cannot use blue. Let me, I need to find a, I'll change this to green. The green color. This one is green color. Green bubble. Well, we can use a different shape. I'll explain what does that mean, okay? Green box, leftover factors. And step 3 is multiply all the framed factors, but when it comes to common factor, write it once only. All right? Let me explain what is the second step and the third step. Write a bubble common factors, common prime factors, like when we looking for GCF, same with earlier. But besides the common prime factors, we have some leftover factors. The 5 here, 2 here, 3 here. I call them leftover factors. Instead of bubble them, I'm going to use a box. That's not the color I want. Yeah, you can use your own color. It doesn't really matter. Bubble this one, and frame this one, box this one. All right, do you see that? Yeah, you can use your own shape. You probably don't have a colored pen. You can just, this is a bubble common prime factors, and use the box to frame those leftover factors. Yeah, everybody can do that. And for LCM, all you need to do is to copy all the framed factors. But when it comes to common factor, you only copy the one time. We have 2 2's in this red bubble, right? You only do the one time. You have 2 3's in the red bubble, you only copy the one time. And then you have 1 5 here. You have 1 2 here. And you have 1 3 here. Yeah, you multiply them all together. Yeah, what do we have here? 2 times 3 times 5 times 2 times 3. 2 times 3 is 6. 6 times 5 is 30. 30 times 2 is 60. 60 times 3 is 180. Awesome. Thank you, Amanda. Okay, very good. Do you see the process? It is part of them is the same with the GCF process. The difference, the first step is the same. The difference, the second and third step. When we look for LCM, we do more. Yeah, okay, very good. Well, if you see it, I want you to apply the process, practice. practice. And find the LCM of 10 and 30. Find the LCM for 7 and 28. Number 3, find the LCM for actually the 5 questions we had earlier. 21, 4, 4, 7. 21, 4. Number 4, find the LCM for 4 and 7. Number 5, find the LCM for 3 and 5. Yeah, same 5 pairs numbers. Earlier we found their GCF. Now we are finding their. Earlier we found their GCF. Now we are looking for their LCM. Knowing the difference, could we do the total of one box color, then multiply it to the other box numbers? Could we do the total of one box color, then multiply it to the other box colors, box numbers? Jill, I don't completely understand your method, but I think can you say it? Can you unmute yourself and explain what's going on? For example, 30 and 36. What box colors? Two times 3 times 5. Oh, the leftover is 30. Oh, yeah, sure. Exactly. I think your technique, your method works. So all that matters is, remember 6 is a GCF. Yeah, to find the LCM, you just need to multiply the GCF by the leftover. Okay, by the leftover, which is the multiplication of the leftover factors, which is 30. Yeah, I get it. Same thing. It's actually same thing. All right, very good. Yeah, that's pretty convenient. You find the GCF first, and then multiply all other leftover factors, and then give you LCM. Okay, give you 5 minutes for that. Number 1 is 30, correct. Number 2 is 28, correct. Number, oh no, it's not. Number 3, I'm sorry, my bad. Number 3 is 21 times 4, 84, correct. Number 4, 4 and 7 is all correct, Paulina. Felina, I'm sorry. Exactly, awesome, very good, very good. I'm using the same 5 questions. Some of you might guess my purpose here. Yeah, I have another 2 conclusions for you to understand and memorize. All right, here. Special case number 1. If we have 2 numbers and the smaller number happens to be a factor of the bigger number, then the GCF is the smaller number. Okay, let me then the GCF of them, then the GCF is a smaller number and the LCM is the bigger number. Yeah, why I'm saying that? Least common multiple, least smallest common multiple of two numbers. Smallest common multiple of two numbers. What happened is 30, yeah, 10 happens to be a factor of 30. 30 is a multiple of 10. So that's the first special case, right? Yeah, 30 is the smallest multiple of itself. 30 is one time of itself. And 30 also a multiple of 10, triple of 10. That makes 30 the smallest common multiple of the two numbers. Same with number 2. 28 is the smallest multiple of itself, one times itself. 28 happens to be a multiple of 7. That makes 28 the smallest common multiple of both, right? And what about 21 and 4? As we factored earlier, 21 is 3 times 7, 4 is 2 times 2. Remember, GCF is 1. On top of GCF, we are going to multiply leftover factors. All of them are leftover factors because they have no common prime factors. So we're going to multiply them all together. When we multiply them all together, is equivalent to multiply the two numbers together. Okay? So the second special case, if two numbers are co-prime, okay, right here. If two numbers are co-prime, their GCF is 1, and their LCM is their product. I put them all together. Combine the conclusions together. Let me repeat the conclusions. Very, very important, all right? If the first special case, the smaller number happens to be a factor of the bigger number, the bigger number is a multiple of the smaller number, then the smaller number is the GCF, the bigger numbers is LCM. Second special case, when the two numbers are co-prime, GCF is 1, LCM is their product. Yeah, once you identify 21 and 4 are co-prime, GCF is 1, LCM is not 1, okay? Yeah, people remember 1 very clearly. Co-prime is 1, GCF is 1, but LCM is not. LCM of two numbers, when they are co-prime, is their multiplication. We multiply 21 by 4, we have 84. We multiply, this case, 4 and 7 are co-prime, so their LCM is their multiplication. 4 times 7, 28. 3 and 5 are co-prime, so their 3 and 5 are co-prime, so their least common multiple is their multiplication. 3 times 5, 15. Okay, yeah. I actually do not mind to type the two conclusions one more time. Some right here, maybe. Special case. Case number 1. Say we have two numbers. If the smaller number is a factor of the bigger number, then the GCF is the smaller number, and the LCM is a bigger number, is a larger number. That's a special case number 1. Special case number 2. If two numbers are coprime, their GCF is 1, and their LCM is their product. Yeah, I want you to understand and memorize. If you only understand today and you don't memorize, maybe tomorrow you don't remember, and then you cannot apply. When you don't remember, you can't apply. If you only memorize, you don't understand, then you'll probably not be able to apply it correctly. You would have to do both, understand and memorize. Yeah, let me know, are we good with those two conclusions? Because we are going to use those two conclusions to solve some problems. Two special cases. Many times when you need to find the GCF and LCM, and they are the two special cases. If they are not one of the two special cases, you would have to apply the 3-step process to find the GCF or LCM. Actually, we should be happy when we have the two numbers that they belong to one of the two special cases, because finding GCF and LCM are so convenient. Yeah, please make sure you have the two conclusions in your note. Understand it and memorize them. Understand them and memorize them. And let me know, are we good to continue? Awesome. Thank you for letting me know for the response. Let's continue. Let's do here. Let's do from here. What's the GCF of 10 to 30? Yeah, you can tell me by seeing it, and I don't have to go back the chat to read it. What's the GCF of 10 to 30?
10.
What is it? 10. Awesome. First, the special case, right? 10 is a factor of 30. 30 is a triple of 10. So GCF of 10 and 30 is 10. What about the LCM of 10 and 30? First, the special case.
30.
30, yeah. 30 is a multiple of 10. 10 is a factor of 30. LCM is a bigger number. Seriously, it'll only take like 1 second. What's the GCF of 4 and 7? What's the GCF of 4 and 7?
1.
Not the 4, okay? This is not special case number 1 anymore. This is special case number 2. The two numbers are coprime. I explained what is a coprime. What about the LCM of 4 and 7?
28.
Yeah, their product. What's the GCF of 5 and 21? 5 is prime. 21 is 3 times 7. Are they coprime? If they are coprime, what's the GCF? What's LCM? Yeah, what's the GCF?
1.
1. What's LCM of 5 and 21? 5 and 21 are coprime. What is their LCM? 110? How do you get a 110? Is 110? What is
I think
21
it's
times
105.
Yeah, 105. Okay. Very close. What's the GCF of 7 and 14, I believe. No, the 11, my bad. It was 11 there. Let me fix it. 11. What is the GCF of 7 and 11? 7, 11. What is it? Knowing 7 is a prime, 11 is a prime, so the two numbers are co-prime. When the two numbers are co-prime, GCF is 1. What about LCM of 7 and 11?
77.
Awesome. Yeah. By the way, we can only do this if they are co-prime. If they are not co-prime, we cannot apply the conclusion. Okay, now it's start to get more complicated, all right? What is the GCF of x cubed and x7? Now start to get more complicated. X cubed and x7. So not the two numbers anymore. Now we are looking at the GCF and LCM of two. We don't need LCM, by the way. Only need the GCF. We are looking for the GCF for two terms. Okay, for two terms. What's the GCF of x cubed and x7? No, x is a common factor, but not the greatest common factor. Let me remind you, this is the first special case. Let me break it down. We have two quantities, not numbers anymore, but two quantities, right? X cubed and x7. You know what? X7 is 1, 2, 3, 4, 5, 6, 7. And the first four x's can be written as x to the power of fourth. The last three x's can be written as x cubed. X cubed happens to be a factor of x7. Do you agree? Do you see that x cubed happen to be, let me write down, x cubed is a factor of x7, right? Because x7 is factored as x to the power 4 times x to the power 3. So x cubed is a factor of x7th, and x7th is a multiple of x cubed. Yeah, not exactly the same with the case in which the two things we have are numbers. Yeah. Here, the two things we have are two terms, but they have the same base. And I want you to agree that x cubed is a factor of x7, and that makes this problem special case number 1. Okay? And then what's the GCF of the two things, two quantities or two terms? Is the factor, right? You see that? Yeah. Thank you, Taylor. Dakota also understand. Very good. Am I clear about that? Maybe I can write this way. Remember, GCF of 10 and 30 is 10. Is because 10 is a factor of 30. That makes 10 the GCF of both. And for GCF of x cubed and x7th power, and x cubed is a factor of x7th. That makes x cubed the GCF of both. Right? Isn't that the same? It's the same thing, right? Yeah. Very good. Thank you. Next, number 24. Amanda. Oh, yes. Okay, I got it. So let's look at number 24. GCF of 97x squared and 14x. This one is very challenging. I just need to get more space here. I have negative 7x squared. I also have 14x. This is a term. This is a term. We are looking for the GCF of the two terms. I want to tell you that when we look for GCF, we do not consider the negative sign. So just ignore the negative sign, okay? To find the GCF of the two terms actually is more convenient than you might think. Yeah. So the first term, coefficient is 97. Second term, coefficient is 14. The first term, variable part is x squared. Second term, variable part is x. So we are going to go by parts, all right? Go by parts. So firstly, anybody can tell me what's the GCF of their coefficients? What's the GCF of 7 and 14? GCF of 4 and 7.
Be 7.
7, exactly. Yeah, 7. First special case, right? 7 is a factor of 14. 14 is twice of 7. And GCF of the variable part, x squared and x. And what's the GCF of x squared and x?
Would it be x?
Exactly. Same with earlier, right? X squared is x times x. So first special case, x is a factor of x squared. X squared is a multiple of x. That makes x GCF. So altogether, combine them together, the GCF of negative 7x squared and 14x is 7 times x. Yeah, we do by parts. So it is negative. We do not consider the sign. Is not square though, Taylor. GCF of x squared and x is x. Yeah. So every term has two parts, remember? Numerical part and the variable part. So we go by parts. We find the GCF of the numerical parts of the two terms. The numerical part 7 and 14, GCF is 7. And then we look at the two terms, the variable parts, x squared and x. GCF of x squared and x is just x. I see where I went wrong. Okay, awesome. Thank you, Taylor. Yeah, let's practice more here. Y cube and a y. What's GCF of y cube and a y?
Y.
What about y cube and a y fourth? GCF of y cube and a y fourth.
Would it be y cubed?
Yeah. So when you see the two powers have the same base, GCF is always the one with the lower degree. Okay, GCF is the one with the lower degree. Very good. And number 25, what's the GCF of x and y?
Would it be 1?
Exactly. Because x and y, two different variables, we treat them as a co-prime. Okay, we treat them as a co-prime. And what's the GCF of x and 5? Is 1 as well, exactly. And what's GCF of x and 3x? What's the GCF of x and 3x? Exactly, x, yeah. First special case again, x is a factor of 3x, right? Yeah, literally 3x is 3 times x. And what is GCF of 3x and 3?
Would it be 3?
Yeah, exactly.
3.
Because 3 is a factor of 3x, right? Yeah, the one goes into the other. And what's GCF? Yeah, that's it. That's pretty much everything. Let's reflect. Reflect on we just have learned 2 conclusions. Finding GCF and LCM. Yeah, mainly I want you to remember the 2 special cases. Not just the GCF and LCM of 2 numbers. I also need you to know how to find the GCF for 2 terms. We can always find the GCF of 2 terms by parts. Look at their coefficients first, and then look at their variable parts after. So that's this topic, GCF and LCM. GCF is so important, especially for chapter 6. LCM is also important because all those chapters we have to deal with. Sometimes we have to deal with fractions. And fractions, in the topic of fractions, we have a concept is called LCD. Yeah, anybody remember what is LCD? LCD stands for?
Is it least common denominator?
Exactly, yeah. LCD refers to the least common denominator of 2 fractions. And anybody remember when do we use LCD? When we deal with fractions. Do we need an LCD when we plus, minus, or multiply or divide fractions? Yeah, you are right. So let me write it down, okay? Yeah. Least LCD refers to denominator, least common denominator. We use LCD when we add or subtract fractions. We do not need LCD when we multiply or divide fractions. Right? Yeah, we do need to know how do we reduce fraction, how do we convert a mixed number to its equivalent improper fraction, and from improper fraction to back to mixed number. We also have to know how to plus, minus, multiply, divide with fractions. So that's gonna be the next topic. Yeah, it's the application of LCM. Let's see, how do we reduce 36 over 30? When we say simplify or reduce something in algebra, we need to firstly understand the criteria. How reduced is reduced? How simple is simplified? A reduced fraction or a simplified fraction. A simplified fraction is a fraction whose numerator and the denominator are co-prime. You see, we use the concept we learned earlier, right? Co-prime. How do we know if a fraction is simplified or reduced? We look at the numerator and the denominator. If the numerator and the denominator are co-prime, then the fraction is simplified or is reduced. And look at the fraction we have, 36 over 30. Numerator 36, denominator 30. Are they co-prime? Are they co-prime? Co-prime means they have no common prime factors. They only have one.
So
you're right. Very good. And anybody remember or can quickly find out the GCF of 36 and 30, the numerator and denominator? 6, exactly. Perfect.
So it would be 6 over 5, right?
Yeah, how do you get a 6 over 5 though? Yes, GCF is 6. Once you find out the GCF for the numerator and denominator, what you can do is you divide both numerator and the denominator by the GCF. Then you can simplify the fraction in one step. If you can find the GCF of the numerator and the denominator of a fraction, and you divide both numerator and the denominator by the GCF, you can reduce or simplify the fraction in one step. 36 divided by 6, 6. 30 divided by 6, 5. And that's it. 6 over 5 is a reduced fraction or a simplified fraction because the numerator and the denominator are co-prime. All right? And you might wonder, some students might ask, do I have to find a GCF in order to simplify a fraction? You don't have to, okay? You don't have to. You're welcome to reduce a fraction through multiple steps. You don't have to get it done in one step. If you know the GCF, yes, you can get it done in one step. But if you don't know the GCF, you can get it done through multiple steps. 36 and 30 are both even, so we know they are both divisible by 2, right? So we can divide the numerator by 2 and then divide the denominator by 2 and simplify 36 over 30 as 18 over 15. And then we do it again. Yeah, 18 and 15 are not co-prime yet. They are not co-prime. Yeah, we know they are both divisible by 3. And we divide by 3, divide by 3. 18 divided by 3, 15 divided by 3, 5. And we can get a process done through multiple steps. You don't have to do one step. Okay? We are allowed to divide the numerator and the denominator of a fraction by the same non-zero number. That is called the division property of a fraction. Division property of fractions. Division property of fractions allow us to divide both the numerator and denominator of a fraction by the same non-zero number. That's why we can do this. All right? Any questions? Yeah, reduce a fraction. Yeah, those actually belong to our foundation 1. Well, anybody can help me to rewrite 6/5 as a mixed number. 6/5 is improper. Improper, proper, mixed number. Do you remember those concepts? Proper fraction has a numerator smaller than the denominator. Improper fraction has a numerator bigger than or equal to the denominator. So 5 goes into 6 one time with remainder 1. Yeah, exactly. 1 and 1/5. Yeah. So you guys have a good foundation from previous algebra class. That's great. Yeah. And next 3 questions are about adding fractions. When we have 2 fractions with the same denominators, we can keep the denominator and add their numerator. Add their numerators. So 3 plus 1. 3 plus 1 is 4. 4/8 is 1/2. So the rule here is keep the bottom, solve the top, reduce the result. Reduce the result. We apply this rule when we add or subtract 2 fractions with the same denominators. And we keep the denominator 8, solve the top, and then reduce the result. When we add or subtract the fractions, we must have the fractions have the same denominators. Yeah, we use LCD. We needed the 2 fractions have the same denominators in order to add them or subtract them. So that's when we need to use LCD, the least common denominator. So number 30, 2/3 plus 1/15. Do those 2 fractions have the same denominators? They don't, right? And what is LCD? What is LCD?
Are you asking what LCD stands for?
Or how do we find LCD? LCD is the LCM of the denominators. Okay, yeah. LCD is the LCM of the denominators. So we have 2 fractions added together. The 2 fractions have denominators 3 and 15. So the least common denominator of those 2 fractions is the least common multiple of the 2 denominators. Yeah. What is the least common multiple of the 2 denominators?
Would it be 45?
They are not coprime. Yeah, we have 2 special cases. They are not coprime. They are the first special case. 45 is a common multiple, but not the smallest common multiple. Is 3 a factor of 15? 3 is a GCF. 15, yeah, 15. Amanda, thank you, Amanda. Is 15, guys. Do you remember the first special case? We have 2 numbers. The smaller number happens to be a factor of the bigger number. Yeah. So the GCF is the smaller number. LCM is the bigger number, right? It's 15. Very good. It's 15. Then we found we found LCD 15. We want to write both of the 2 fractions as their equivalent fractions with denominator 15. How do we get that done? The second fraction already has a denominator 15, so we don't have to worry about that.
You would multiply by 5 on
multiply. Exactly. Multiply by 5. Yeah, that is called a multiplication property of fractions. Multiplication property of fractions allow us to multiply both the numerator and the denominator by the same non-zero number for a fraction without changing the value of the fraction. So that's the reason we could multiply numerator and denominator by 5 in order to make the denominator become 15, right? So the numerator become 10. 10 over 15 plus 1 over 15, when they have the same denominators, we are able to add them up. What's the rule? This is the rule. Yeah. Actually, we use this rule very frequently. We keep the bottom, solve the top. 10 plus 1, 11, and reduce the result. Is 11 over 15 already reduced?
Yes.
Because 11 and 15 are co-prime. 11 is prime, 15 is 3 times 5. They have no common prime factors. Today, we learned tons of information. To be honest, it's a lot of information today. But I'm recording the class. You're welcome to rewatch the lesson and reinform those concepts. What we learned today is very basic and very useful. Not only you use it in algebra, when you go to pre-algebra, you still use it. When you go to calculus, you still need it. Actually, in pre-calculus, you need those stuff more frequently than this class, in fact. All right, so that's how do we add 2 over 3 with 1 over 15. Next question, we have a negative 1 over 2 plus 1 over 3. Those two fractions do not have the common denominator. So we need to find their least common denominator. Their least common denominator, LCD, is the least common multiple of the two denominators. Anybody can tell me what's the LCM of 2 and 3?
6.
Exactly. Yes, 6. Thank you, Jamie. Yeah, rewatch the lesson is a good idea. Yeah, it's totally fine that you don't completely remember or grasp the whole thing because tons of information. It's tons of information. So that's the reason I'm recording it. Yeah, 6. LCM of 2 and 3 is 6 because 2 is prime, 3 is prime, 2 and 3 are co-prime. Their LCM is their product, 6. Okay, so that means we are going to rewrite both of the two fractions as their equivalent fractions with the denominator 6. Okay, how do we go from 2 to 6? By multiplying a factor. From 2 to 6, we are missing factor 3, right? So we multiply both the numerator and the denominator by 3. And from 3 to 6, we are missing factor 2. So that's why we multiply both top and the bottom by 2. One times 3 is 3. Yeah, negative. 1 times 3 is 3. 2 times 3 is 6. 1 times 2 is 2. 3 times 2 is 6. So we have a negative 3 over 6 plus 2 over 6. They have the same denominators. We apply the rule. Yeah, once we have the same denominators, we apply this rule. As I mentioned earlier, we actually use this a lot. Yeah, remember that. I make my students remember that. keep the bottom, okay? Keep the bottom 6. Solve the top. Don't forget this negative sign. Solve the top. You see what I'm? You include negative sign with the numerator. So we have solve the top. We have negative 3 plus 2. What is negative 3 plus 2? In case you don't, what is it?
-1/6 or negative
yeah,
1
negative
over, yeah.
Yeah, very good. In case you don't remember how to add numbers with signs, use the casino method we learned last time. First game, you lost $3. Second game, you gain $2. You end up with losing $1. So this method this trick works very well when you deal with numbers with signs. Just use the casino method. And by the way, I want to introduce another formula here. For fraction, if we have a negative fraction, we can move the negative sign in the numerator or in the denominator. And they are all the same. They are all the same. Yeah, we can move the negative sign in the numerator or denominator. That's the reason -1/6 can be written as -1/6. They are the same thing. Yeah, there's a formula behind it actually. All right, that's how do we add fractions. 3 questions. Multiplying fractions. Number 32, I'm going to introduce a butterfly method. To multiply fractions. It's 45. I think I want to pause here and leave actually 4 minutes for questions and answers, because we are not going to get the topic done within 4 minutes. So we're going to pause here and continue on Wednesday talking about the butterfly method. So GCF and LCM, let's summarize. Very, very important thing is today we learned 2 conclusions, 2 special cases, finding LCM and GCF. We have 2 special cases. If we have 2 numbers and one it happens to be a factor of the other, then the GCF is the smaller number, the LCM is the bigger number. If we have 2 numbers that are co-prime, then their GCF is number 1, and their LCM is their multiplication. Yeah, a common mistake is mistake LCM of 2 numbers as 1 when they are co-prime. Yeah, LCM is not 1. When the 2 numbers are co-prime, their LCM is their multiplication. Because the GCF is a relative smaller number, LCM is a relative bigger number. Yeah, you must remember that. When we look for GCF of 2 numbers, we are aiming at a smaller number. When we look for LCM of 2 numbers, we are looking for a relative bigger number, because the number has to be multiple of both, right? Even is the smallest multiple of both. Any questions that you have? Any questions about today's lecture or enroll in MyLab Math? Did I see anybody raise hand or? Okay, Kayla has no problem. Jill says need practice. Exactly, I agree. Remember I told you about my teaching philosophy? I believe practice the same good question 10 times is more efficient than practicing 10 different problems. So you have my notes My notes is posted in Blackboard. My recommendation is you redo those questions multiple times. You don't have to look for other problems. Yeah, if you really thoroughly understand those examples, you should be able to do other similar problems. Yeah, thank you. Well, if you have no questions, I would say good night, and I'll see you guys on Wednesday. Thank you.
Good night.